In this video, we'll understand semantic search with embeddings in a simple step-by-step way. We'll see how items like images, text, audio, and user behavior can be turned into vectors, indexed efficiently, and searched quickly. Along the way, you'll also get short quizzes to check your understanding. We live in a world with too much information. Whether it is clothes, songs, recipes, movies, or houses, users want the right result quickly. Earlier, people could organize information manually, but with internet-scale content, that approach simply does not work. Search systems became necessary to retrieve relevant items in milliseconds. At its core, search is about fulfilling an information need. A user gives a query, maybe text, an image, or even a list of items, and the system returns relevant results. Classical search relies on representations and indexing structures that make retrieval fast and scalable. Traditional retrieval methods like TF-IDF, PageRank, inverted indices, and simple image descriptors are powerful foundations. But many of them mainly capture surface patterns. They often struggle to understand meaning, intent, similarity, and context deeply. That is where semantic search becomes useful. Now let us look at this in a simple table format. Classical vs semantic search. Main idea behind modern retrieval. Here is the main comparison. Classical search usually focuses on exact terms, fixed descriptors, and surface-level similarity. Semantic search moves to embeddings, where items are represented in vector space. This makes it easier to retrieve results based on meaning, across text, images, audio, and more. Semantic search uses small vectors called embeddings to represent items. These vectors capture meaning, not just exact words or simple features. Because of that, the system can match similar ideas, similar images, and related content even when the query and the item are not identical on the surface. Now that we've covered search basics, let's test what we've learned so far. Here's quiz number 1. See if you can get it right. Question 1. Why did manual indexing become insufficient on the internet? The correct answer is, content grew too fast and too large. The article explains that the number of documents exploded from millions to billions, making manual indexing impossible to maintain. Question 2. What is the main goal of a search system? The correct answer is, to fulfill an information need. Search starts from a query and aims to return relevant items that satisfy what the user is looking for. Question 3. What is the key difference in semantic search? The correct answer is, it uses vectors called embeddings. Semantic search represents items as small vectors, which helps capture meaning and similarity. Semantic search can power many real systems. A text search engine can find articles or products. A visual search system can take an image and return similar items. A recommendation system can use user context and behavior to suggest movies, products, or news. The same core retrieval ideas support all these applications. A semantic search system is usually built in two major parts. First is the encoding pipeline, where items are converted into embeddings and organized into indices. Second is the search pipeline, where user queries are processed, encoded, and matched against those indices to retrieve the best results. Before encoding anything, we need to decide what information matters. For some items, images are most important. For others, text, user interactions, popularity, or graph relationships may matter more. The right choice depends on the product goal. For visual search, image content may be best. For recommendations, co-occurrence and behavior may be stronger signals. Content encoding turns raw data into vectors. Images can be encoded using models like ResNet or EfficientNet. Text can be encoded using word embeddings, transformers, or BERT-style models. Audio can also be embedded for applications like music recognition. This is the heart of semantic retrieval: convert different types of content into a common searchable representation. Now that we've covered pipelines and data, let's test what we've learned so far. Here's quiz number 2. See if you can get it right. Question 1. Which two major parts make up a semantic search system? The correct answer is, Encoding pipeline and search pipeline. The article clearly describes semantic search as having an encoding pipeline and a search pipeline. Question 2. For a visual search system, which signal is often most relevant? The correct answer is image content. The article notes that for visual search, the picture itself is often the most relevant information to encode. Question 3. Which model family is mentioned for image encoding? The correct answer is ResNet. ResNet and EfficientNet are mentioned as strong feature extractors for images. Image retrieval is not just about encoding the full image. Sometimes we first detect or segment parts of the image, like shirts or pants in a fashion photo, and then encode those regions. Also, the training loss matters. Contrastive loss and triplet loss usually help bring similar items closer, while classification losses often group items by class labels. Text can also be embedded at different levels, from words to full documents. Word2Vec helped popularize semantic representations for words. Then transformers improved how long-range context is handled. BERT-style models pushed this further and made text representations much more powerful for retrieval tasks across many languages and domains. Once embeddings are generated, the system must scale. Large batch jobs with tools like Spark or PySpark can encode huge datasets efficiently. Modern models can process thousands of samples per second, and indexing structures make later retrieval fast enough for real-world systems handling millions or even billions of items. On the search side, the system takes a user query, identifies the useful parts, converts that query into an embedding, and searches the right index. After retrieval, post-filtering can apply business rules, constraints, or quality checks before the final results are served to the user. Now that we've covered encoding to serving, let's test what we've learned so far. Here's quiz number 3. See if you can get it right. Question 1. Why might segmentation be used before image encoding? The correct answer is to extract important parts of an image. Segmentation can isolate relevant objects or regions, such as clothing items in a fashion image. Question 2. Which text model family is highlighted for strong contextual representations? The correct answer is BERT. The article describes BERT as a major step forward for text representation and retrieval. Question 3. What usually happens after searching an index? The correct answer is post-filtering and serving. After retrieval, systems often apply filters or constraints and then serve the final ranked results. That's the core idea of semantic search with embeddings. If you understand vectors, indexing, and the two-pipeline design, you already have the foundation to build powerful retrieval systems. Keep exploring, and you'll see that almost anything can be indexed and searched semantically.